there is a block of mass capital M and another block of mass small m in the situation shown in the figure. And just look at this pulley, we will assume that these are ideal massless pulleys, and a single piece of string is there, and through that single piece of string the small m is suspended. So what will happen, that the small m will move down due to gravity, and it will put a strain on this string, and the string will pull this block to the right. So besides coming down of the small m will be also pushed to the right in the situation. So what is our job? Find the acceleration of the block of mass capital M in the situation in the figure. Now the coefficient of friction between the two blocks is mu1. Here the coefficient of friction is mu1, and the coefficient of friction between the bigger block and the ground is mu2. Here we will remember it to be mu2. We have to be very carefully making the free body diagram here. Just consider the free body diagram of this mass capital M, and simultaneously we should know that if capital M, this bigger block, suppose it moves to the right by x, moves to the right by x, then what will happen? This point and this point moves to the right, so here x and here x, 2x length of the string becomes free. So 2x length of the string becomes free, and as 2x length becomes free, this will give the small m the opportunity to move down by 2x. So small m object, this block which is suspended I am talking about, gets opportunity to move down by 2x. Now when the small m moves down by 2x, simultaneously small m moves to the right also by x. Therefore if capital M is moving with an acceleration a to the right, small m will be also moving with the same acceleration a to the right, and simultaneously it will be moving down with an acceleration 2a. So let us take small m also. It will be moving down with an acceleration 2a and moving to the right by acceleration a, and this block of mass capital M, it will be moving to the right with an acceleration a. Now what are the forces? Small m will be acted upon by its own weight, small mg. The tension is there, capital T. It will be pushed with a normal reaction N, which the same normal reaction acts here also. As small m moves down, just look at carefully, so the friction will be acting here in this direction, which will be equal to mu1 into n, and the same corresponding friction will be acting along this vertical wall, and it will be equal to mu1 into n. Further, as these forces are there, let us see the corresponding forces on the bigger block. Now this pulley is a part of this block, I hope you have noticed, and the tension here, this is T and this tension is T here, and this tension is pulling it to the right. As a single piece of string is used, so therefore we will be taking the same tension throughout. Apart from that, there will be capital Mg, there will be normal reaction from the ground, let's call it N dash, and as it moves over the floor, therefore the friction will be acting here mu2 into N dash. Just look at here, the mu2 is the coefficient of friction between the block and the ground. Now is the term to write the corresponding equations which we will be trying to solve to find out the acceleration. Let's check in a continuity of this free body diagram. Just look at the free body diagram. I am putting the paper here. For the block, now for the block, horizontally first of all, in horizontal direction, the net force, keep on observing, it will be 2t minus n, here n is there, be careful about the solving, minus mu2 into n dash, and this will be mass into acceleration, the friction I have taken. And the vertical, in the vertical direction things are balanced. So therefore n dash will be counterbalanced by mg plus capital T plus mu1 into n. Look at this force. This is in the vertical. And for the suspended block, for hanging block, this is of mass small m. This mass was capital M. For this, let's look at the free body diagram. Here what we can have is this horizontal direction. In the horizontal direction, this normal reaction N is creating the net force, that is mass into acceleration. And in the vertical direction, as I told you, it will be moving down with an acceleration 2a. Therefore, we can have mg minus t minus mu1 into n. Just keep on observing. And this is equal to mass into acceleration, which is 2a. Now, once you have noted down these, let us concentrate on these equations for the solving purpose. Now, during solving, what I can say is, from here, let us find out T. Just I put N as MA, and from there, T can be worked out as mg minus mu1 into N I am putting as MA minus 2MA. Maybe this T comes as a handy value to put it here. Now, in this here, N dash, we need to put this N dash here. So this N dash will be equal to mg. This is N dash is capital Mg, mind it. This is capital Mg here, and this is T plus mu1 into N. What is N? N is Ma, that is mass into acceleration. Now this equation, let us sort out. What is there? It is 2T minus normal reaction M, N is Ma, and plus mu2 into N dash. What is N dash? N dash I am putting here, segregating all the terms, and we have mu2 into capital Mg minus mu2 into tension minus mu1 mu2 Ma is equal to capital Ma. I have simply written this, putting this value of N dash. Now let us put this value T. First, what you do, this is 2 minus mu2 into T. Which T? This T, I will put it from here. So it will be equal to mg minus mu1 Ma minus 2 Ma, and I am continuing with all the terms as it is, minus Ma minus mu2 capital Mg minus mu1 mu2 Ma is equal to Ma. Now what I do, I am opening up the bracket, and one by one I am transferring all the A containing term to one side, and the other terms which does not contain A will remain in one side. So this will be equal to, keep on observing, capital M plus small m plus mu1 mu2 small m plus 2m 2 minus mu2, and then further it will be plus mu1 into m into 2 minus mu2. All these contains A. Here I have taken this, and in this side it will be 2 minus mu2 into small mg minus mu2 into capital Mg. This we get. Now what I do, I will now simplify it. Let's check the acceleration, and capital M plus small m plus mu1 mu2 m plus 4m, I am simply opening up the bracket, nothing special, minus 2m mu2 plus 2m mu1 minus mu1 mu2 small m, and on the other side all are containing small g. So what you can do is 2m minus mu2 common, capital M plus small m, and together you can put small g. Now what is A? This is 2m minus mu2 into capital M plus small m into g. G is with both of them, divided by, now let's see, only capital M is there. You may be able to see that these two terms, they get cancelled because one is positive and negative, and now I am going to put this capital M plus this is a small m, and C4m plus this is 5m, so I am taking small m common, so it will be 5 plus 2 times mu1 minus mu2. So this becomes the acceleration value of the block. Just you can pause the video and see it for your own satisfaction and check all the calculations.